So I'd like to sort of talk about a question here that is sort of a deviation from the traditional approach that is usually taken when working with moles and conversion factors. This question in particular sort of tells us to find how many sulfate ions are in 86.2 grams of aluminum sulfate. So first and foremost, you have to have some recognition of what aluminum sulfate is. It's not an elemental. It's essentially not just a singular element. In this case, it's a polyatomic ion, which is of course differentiated from molecular compounds. It's an ionic compound, and since it's an ionic compound, we need to balance the charges out. Aluminum itself is just an element, right? With a +3 charge. In other words, it wants to lose 3 electrons in order to sort of achieve noble gas electron configuration. But the idea is that aluminum by itself is essentially being merged with sulfate. Now it's not sulfur in this case; it's actually sulfate. This one here, if you were to look up what sulfate is, you would get it's actually SO4, and it has a net charge of -2, or actually 2 negative. And so what this tells us is that sulfate is actually not just it's not just sulfur. It's actually made up. It consists of these 2 elements, and you would essentially call that sulfate. Now, the thing is that when you're working with ionic compounds, the goal is to always neutralize the charge. And in this case, the charge is not neutralized between both I can't say elements, but between aluminum and this polyatomic ion here. It's not, the net charge is not balanced. It's 3 and there's 2 minus. So we want to be able to balance the charge. In other words, get the net charges equal to the same number. Now, conceptually, you could think of that as being, okay, well, if I have aluminum with a +3 charge and I have SO4, which is just sulfate, with a 2 negative charge, if I were to add one more Al, or aluminum, what would that essentially get me to? Well, it would get me to a net charge of 6. And if I were to do the same thing with SO4, if I were to add one more SO4, well, that would give me to a net charge of 4. So that it still really doesn't balance out. You have 6 as a net charge for aluminum, and you have 2 as a net charge for SO4. So the goal here is to balance the net charge. There's an easy way out, and the easy way out is to say that, okay, if I add one more SO4, then essentially I would have 6 on this side and 6 on this side. So if I had one more SO4, I'd have -6 on this side as total, and I would have +6 on this side, and both of these cancel out and give me a net charge of 0. So you've balanced the net charge, and of course you want to figure out how many it took you to do so. It took you 2 Al, it took you 2 aluminum atoms, and it took you 3 SO4 atoms, or 3 sulfate atoms. And so that is essentially your chemical formula for aluminum sulfate. And the idea is that, of course, there is an easier way around it if you don't want to think about it conceptually. You could instead just say that, okay, I'm going to sort of lasso this down. You'll have Al2 and an SO4. So the atoms, the charge essentially become the atoms. And that essentially brings us to the same answer that we got before. So we're dealing with ionic compounds. We're dealing with an ionic compound here. And we just want to make sure that the charge is neutralized before actually working with it. And so we had Al2, we have 2 Al atoms and aluminum atoms rather, and we had sulfate, which was SO4, and that in total has 3 atoms or 3 molecules of SO4 in order to, or ions, you can think of it as an ion. You need 3 of them in order to balance out the net charge. So for every 2 aluminum ions or atoms, you would need 3 SO4 in order to balance out the charge. That is essentially a ratio here, but we're not actually talking about ratios. Instead, what we want to do is we want to find how many sulfate ions are in 86.2 grams of aluminum sulfate. In other words, this is what we're considering to be the sulfate ion. And we want to know how many, so we want to know how many ions there are in these many in these many grams of aluminum sulfate. So this as a whole is considered aluminum sulfate. And this is just a singular compound, right? It's just you can think of it as a molecule. And this is in fact a molecule, a singular molecule. But if you had 86.2 grams of this substance, of aluminum sulfate, as a whole, how many sulfate ions would you have, right? How many of, basically what it's asking you is how many of these would you have? How many SO4s would you have? So you know that this as a whole is considered a molecule. And in this molecule in particular, in aluminum sulfate, there are 3 SO4. There are 3 SO4. Basically, it's sort of a molecule within a molecule, kind of, but there are 3 SO4 ions in one molecule of aluminum sulfate. So if I have 86.2 grams, the approach is going to be, well, how many molecules is that, right? How many molecules is that? Let's say if it were X molecules. So if it were X molecules, then there would be 3 per molecule. So if I were to figure out, hypothetically, how many molecules are in 86.2 grams, I know that there are 3 ions per molecule. So 3 times the total number of molecules will essentially give me how many sulfate ions there are. So it becomes important at this stage to be able to figure out how many molecules are actually in the substance that in the gram amount that we're given. How many molecules are there in 86.2 grams? So in order to figure this out, what we essentially want to do is we want to go from grams, and let me change my color here. We want to go from grams to molecules. And this is true because we want to be able to say, okay, well, if I know how many grams, if I know X amount of grams is these many molecules, then 86.2 grams will be how many molecules? That would essentially be a proportion that I could set up in order to solve. So, you're looking for something, you want to equate grams to molecules in some way. And the most obvious way, if you were to look through your conversion factors, is that you could say that 1 mole is equal to these many molecules, right? And actually, what this would do, what you could do in this case is you could use the molar mass conversion, which gives you grams per mole. And what the grams per mole does is you find the molar mass. And once you have the molar mass itself is expressed in terms of a particular amount of grams per mole for that element. So you find the molar mass, and then you can actually equate the molar mass in grams to the amount of molecules that would be in that amount of grams. In other words, if I have, so the thing is, first let me find the molar mass of aluminum sulfate. And the molar mass of aluminum sulfate would, in grams, would equate to a particular amount of molecules. In fact, 1 mole molecules. And then you could figure out how many, you could toggle the amount of grams, and then you could find out the corresponding amount of molecules. So I'll show you what I mean. So I have Al2, right? And then I have SO4. I have 3 of these in 1 molecule. So my molar mass, and this is what we're doing on the side here, we're finding the molar mass. So the molar mass in this case, if I were to, take their atomic numbers and add them, the atomic number for aluminum, the atomic number for aluminum is 26.98. So 26.98 grams per mole. And, really we're looking at AMU, but when we're talking about molar mass, we're shifting into grams per mole. And then since I have, so this is like 26.98. 26.98 is for 1 aluminum atom. But if I were to have 2 of them like I do here, I would essentially have to multiply this by 2. That would reflect the accurate molar mass. And then, of course, in SO4, in this ion here, I have one sulfur atom. Or actually, I don't have one sulfur atom. I have 3. You can think about it as I have SO4, but I have 3 of them. So it's essentially one sulfur per ion. And since I have 3 in total, that would essentially be 3 sulfurs. So I actually have 3 sulfurs. So one sulfur, if you were to look up the atomic mass for that, you would have 32.07. And then if you were to multiply that by 3, just to take into account that you actually have 3 sulfurs, you would get the accurate molar mass. And of course, with oxygen, right? I mean, you have 4 per molecule. If you were to sort of not look at the 3 here, you have 4 oxygens, but you also have 3 ions, right? You have 3 sulfur, you have 3 sulfates. So it's 4 per sulfate, which would essentially mean that you have 4 times 3, which is 12. You can almost think about this as distributing the 3 inside the parentheses. So you would essentially have 12 in total if you had 3 SO4s. So what you would do in the atomic mass, if you were to find the atomic mass of sulfate, it's actually 16. So 16 times 12 would actually give you how many aluminum, or how many, it would give you the molar mass of oxygen. And if you were to add all these together, you would get the total mass of the entire compound, or the molar mass. So if you were to do 26.98 times 2, of course, because we're taking into account we have 2 aluminum atoms, and you were to add that to 3 times 32.07, taking into account you have 3 sulfur atoms, and then you were to add that to 16 times 12, taking into account you actually have 12 oxygen atoms in one molecule of aluminum sulfate. You would come across to a number of 342.17 grams per mole. And so this grams per mole is essentially the unit that we're working in. And what this means in this context is that you have in 342.17 grams of aluminum sulfate, Al2SO4, there are 1 mole molecules. But you can sort of change this definition so that it suits you. When you're talking about grams per molecule, you're essentially, grams per mole. The mole in this case, since we're dealing with a molecule, is in fact Avogadro's number of molecules. So you actually have what you actually have is 6.02 times 10 to the power 23 molecules in these many grams of aluminum sulfate. So what this tells you is that you now have the proportion that we were talking about. In order to go from grams to molecules, we had to first go through grams to moles. And since we knew we were talking about a molecule, we knew that we could equate the mole to molecules. So you would actually have 342 grams is equal to these many molecules. If you were to toggle the amount of if you were to toggle the amount of grams, you could find out how many molecules you would have. And if you could toggle the amount, or if you wanted to toggle the amount of molecules, you would figure out how many grams that would be. And that's why we call it a conversion factor, because it allows you to convert from A to B or B to A. So so 86, right, you have 86.2, and you're just using your conversion here. 86 point, and this is one method, right? And I'll go ahead and show you one method here. So you would have 86.2 grams, and you want to convert this to, and this is of course of aluminum sulfate. So just keep in mind that we're talking about aluminum sulfate here. And you want to essentially, what you want to do is you want to make sure that your grams of aluminum sulfate cancel out in order to convert to molecules. So and the only way to do that with this conversion factor is if molecules, or rather grams, if that were on the bottom. So you'd have 342 86.17 grams on the bottom so that your grams would cancel out. And your molecules, the only unit that you actually want to express these grams in, would be on the top. And so what this would do for you is your grams would cancel out, and you would be left with a molecular equivalent, so to speak. So you would actually have, if you were to solve this, if you were to put this in your calculator, you would have 86.2 grams, or how many molecules are in 86.2 grams of aluminum sulfate. And if you were to do that in your calculator, you would have, let's see here. So you would have, so I would actually have to put this in a calculator in order to. The answer that you would essentially get is 1.51 times 10 to the power 23. And this would, of course, be in molecules, right? Because you have to take into account that your grams essentially canceled out. So you're not dealing with grams anymore. You're dealing with your molecular equivalent. And so, I mean, you know now how many molecules are in 86.2 grams of aluminum sulfate. But your original question was to figure out how many sulfate ions there are in 86.2 grams of aluminum sulfate. Or in order to rephrase this in a manner that is convenient, you could just say how many sulfate ions are there in these many molecules, right? So you have 1.51 times 10 to the power 23, and you want to figure out how many sulfate ions are in these many molecules of aluminum sulfate. So this here is AlSO2 or Al2SO4, right? And then, but you're wondering, what you're asking yourself is how many sulfate ions? In other words, how many per in these many molecules, how many of these of SO4s do you have? Well, again, looking at the sort of the chemical formula here, you can understand that you have this is one molecule, right? And this is a huge number of molecules, and it's clear to see that you have 3 per SO4. You have 3 molecules, or sorry, 3 SO4s per molecule, right? That's what this tells us. And so if you had these many molecules, you would just have 3 times the amount of molecules that there are. So you'd have 1.51 times 10 to the power 23. And that essentially would give you how many, SO4s you would have. And just to confirm that, let me go ahead and put it into a calculator. That would definitely give you the right answer. But what I want to tell you is that there is a sort of another way of getting to this answer. Now, you could think of it intuitively like this, or you could extend your conversion factor. And so what I mean by extending the conversion factor is basically that if you remember our original conversion, what we said was that if you recall, we had 342.17 grams. So we had 342.17 grams equals 6.02 Avogadro's number, basically, to the power 23 atoms, right? Atoms, or actually molecules in this case, since we're dealing with a molecular compound here, or not a molecular compound, but a molecule. And so these many grams of Al2SO4 would give me these many molecules of Al2SO4. And so the way to, sort of another way to do this is to say that, okay, well, how many, so first you would ask yourself, okay, well, how many molecules would I have if I had 82, or I think it was 86.2 grams? And that's essentially the first question. And so your first conversion would essentially look something like this. You would say, okay, I have 84 or 86, 86.2 grams, right? How many, and this is of course the same conversion that we had before. How many molecules would I have? Well, you would want your, you would essentially want your 342.17 grams. You would want your grams to cancel out, and so this is what that would do, and You want your molecules to stay, so you would have 6.02 times 10 to the power 23 here. And so once you do this, you would eventually be left, this unit here, if you were to do this, you would be left with how many molecules that would be. But you could extend the conversion factor one more step ahead to say that, okay, well, how many, that's really not what we're trying to convert into, right? Our goal is not to figure out how many molecules there are in 86.2 grams. Our goal is to figure out how many ions of sulfide there is. And so what you would do is, I mean, this would give you the molecules, and you want to somehow convert the molecules into ions of sulfide. And so what you would do in order to do that is you would need a ratio that would allow you to be able to cancel molecules. I mean, these grams, you can think of these grams as already having been canceled. The answer that you would have from this guy here would be in molecules. And so you would need, I mean, if you didn't extend this conversion factor further, you would just have an X amount of molecules. Let's say this number was, I don't know, 728, but that's impossible. It's just an example. If you had 7,028 molecules, you would want to have a conversion factor that could get you to sulfide. And the only way to do that is if you have some amount of molecules on the bottom and some amount of sulfide ions on the top. So you're looking for a conversion factor here, and the conversion factor is obviously, as we said before, that there are three, and if you were to look at the formula here, Al2SO4, and there are of course three of these, there are essentially in total, there are 3 SO4 per molecule. So you could say that there are 3 SO4 ions per molecule, and this is of course a ratio per molecule of Al2SO4. So this is of course a ratio. You could say that the 3 SO4 for every one molecule. And you could express this as a fraction, but you want to express it as a fraction in a way that you could put it here so that your molecules would cancel out. So you could say 3 SO4 ions is equal to 1 molecule, and your molecules would cancel out. And the number that you essentially got from here would sort of bleed into this conversion factor, and then you would get the amount of ions that you would have. So, sort of extending this conversion factor here without really stopping it too early, what you could do is you could just say that 8.86.2 grams multiplied by these many, by this fraction here, and then you just multiply again, because this would give you an answer, but then you would multiply again into the final answer that you would want. The grams would cancel out, and you would be left with 3 ions, right? 3 SO2 ions, or SO4, for every 1 molecule. So your molecules would cancel out, and you'd just be left with the final answer of how many ions that would be. And so if you were to do this in your calculator, if you do 8.86.2 multiplied by, of course, the fraction that we just, by Avogadro's numbers, 6.02 times 10 to the power 23. And of course, in your denominator, you would have your amount of grams that eventually canceled, which would be 342 times, or 0.17. And then that would be multiplied by 3 divided by 1. And you would have, again, the same amount that we had before, right? If you were to do this, you would get, if you were to do this here, you would get 4.53. And if you were to do this conversion, you would also get 4.53 or 4.54, a rounded answer. So that's essentially how you want to extend your conversion factor here, and really think in terms of atoms and molecules and whatever can help you get to the right answer.